All right, here we go. So let's finish up this 6-4. It was rectangles, rhombi, and squares. Everybody's listening now. We've started. Started. All right, so let's take a look. They tell you that this thing is a rhombus. Okay, so they tell you that this is a rhombus. So they say it's rhombus. I think they call it ABCD. A, B, C, D. So since they tell you it's a rhombus, okay, they already tell you that it's one. So what could I say about some of the stuff that's going on here? Definition of a rhombus. What's that mean? It's a four-sided figure with what? Okay, it is a parallelogram. That's true. So everything we know about a parallelogram is true. But what's specifically about a rhombus? All what? 4 equal sides. That's it. 4 equal sides. So let's mark them. So this side, this side, this side, and this side. All right? So that's specific about a rhombus. That's not true about every single parallelogram, is it? Okay, but it is true about a rhombus. What else do we know about a rhombus? What about the diagonals? What do the diagonals do on a rhombus? Okay, they are perpendicular. Very good. Is there anything else that we know? What about being equal to each other? Are they equal to each other on a rhombus? No, but they are equal to each other on a what? Rectangle. Okay, but this is not a rectangle, so the diagonals are not equal to each other. They are perpendicular, so that's good. So that's one thing that I can find right now. So what's angle 1 without doing any math at all? 90 degrees, that's right, because these diagonals are perpendicular. This is angle 1, so already we've got one of our answers. Everybody see that? Okay, what else? Somebody said that this was a parallelogram, which is true. What do we know about parallelograms? The diagonals also do what? Bisect each other. I don't think we're really going to use that here because they don't even ask you for the lengths of the diagonals or the lengths of the segments or anything. They're just asking for angles, right? Yeah, every single one of these is angles. So the fact that all 4 of these sides are equal to each other isn't really even going to help us with solving these problems. So what else do we know about a rhombus? We said that the diagonals do something to the angles. What does this diagonal do to angle A and angle C? They bisect them. That's right. We just learned that yesterday, okay? So this diagonal bisects this big angle A and this big angle C. So angle 2, without really doing any math, we should be able to figure out what angle 2 is. What is it? 34. That's right, because if it's bisected, it splits it into 2 equal angles, correct? So if I know one of the angles, the other angle has to be the same thing. So let's just write that in there. 34 degrees. And I'll put it up here. 34 degrees. So I got 2 answers already. I didn't even have to do any math. Didn't have to do any arithmetic, but you did have to know some stuff, all right? You had to know on number 1 that the diagonals are perpendicular. So you had to know that to be able to say that that's 90 degrees, right? I didn't have to add anything, subtract anything. I didn't do any algebra. All I had to know was not the definition. I needed to know the theorem that says that the diagonals are perpendicular. Angle 2, I needed to know a theorem that said that that diagonal bisects the angle, all right? Didn't have to do any math, right? I just look, I'm like, oh, okay, well, if that's 34 and this is being bisected, that means that's 34. Everybody with me? All right. What do I know about big angle A and big angle C? They are being bisected, we know that, but what's something else? Because it's a parallelogram, what do I know about the opposite angles? They're equal to each other, exactly right. Okay, so let's, they're asking for angle BAD, this bad angle right there, okay? So what's angle BAD? There's B, there's A, there's D. We're asking for that big angle right there. Well, that big angle A is equal to what? Big angle what? C, that's right. So those 2 are equal. And now I have to do a little math, don't I? All right, kind of. You could probably look at this and just see what it is, but you kind of have to do some math. So what's this big angle C? It's what? 68, right. What's big angle A then? It's 68. But this is bisected, so 3 is what? Half of 68, which is, I'll just put it right there, 34 degrees. Now, you could have just looked at it and said, oh, this one, this one, are all the same. I think we did that yesterday, didn't we? Yep. If you look at the video, watch it. This angle and this one are the same. And since the two big angles are the same, then this little one and this little one are the same. Yes? Well, the whole thing is 68. The whole big angle A is 68. So that means this is 34, and this one right here is also 34. Yeah. Yeah, if they're asking for the whole thing. Oh, my bad. Yeah, you're exactly. I know what you're saying now. Absolutely right. I was. That's my bad. You're absolutely right. Thank you for pointing that out. This is asking for the whole big angle, isn't it? All right. For some reason, I was just looking at the one angle. Don't know why I did. It might be another one. No, it's not even another one. But BAD is the whole big angle, so it's 68. Yeah. So you're absolutely right. I messed up. All right. But if they did ask for these two little angles right here, they would both be 34. Everybody good? All right. Angle 3. Oh, they do ask for angle 3. That was this one right here. All right. We just did it. So angle 3 is what? 34. All right. ABC. Where's that? ABC. That's this. It's too much white. Let's put some color in here. Let's go pink. All right. So look. Stop. I know what you're thinking, okay? They're colors, for goodness sakes, okay? Everything doesn't have to be about that, all right? So here we go. This angle right here is what we're trying to find. That's angle ABC. ABC. Well, I know that whole big angle, and I know this whole big angle. What's true about big angle B and big angle C? They're supplementary. That's right. So what math? We do have to do a little math on this one, okay? So how do I find the whole big angle? Okay, and that's what they're asking for, ABC. That's exactly right. So it's 180 minus what? 68. And what's that? 112, is that right? Yep. 112. So angle ABC, this whole big angle, is what? 112 degrees. That's the whole big angle. All right, we just talked about this next part. So this next part's kind of same thing as we did before. We want to find now angle 4. So what's true about angle 4 compared to the whole big angle? It's half of it, exactly right. So what do? You just take half of 112. What's that? 56, is that right? Yep, 56. And there you go. Easy as that. So is that something you think you can do on a quiz? Should be. All right, it was pretty easy. Silas. Okay. Because supplementary means they add up to 180. All right. No, not A and C. A and C are equal to each other. The ones that are not across from each other, we call them consecutive angles. They're the ones that are next to each other. So angle B and angle C would be consecutive angles. All right. That means they add up to 180. So if I know one of them, then I can find the other one by taking it away from 180. All right. And that's what we did right there. I knew this one was 68. I knew that the two together added up to 180, so I took it away and got 112. Does that make sense? Now, what else is consecutive? Since he brought that up, B and C are consecutive. What else? C and D are consecutive. What else? D and A, and one more, A and B. All right, so you could look at them a bunch of different ways, right? Everybody good? What's that? Emailing? Okay. All right. Everybody good with this? Any other questions on this before we move on? It's pretty straightforward, I think, don't you? Yeah, you just got to know stuff. All right. The math was not hard. Would you agree? The math was very, very easy. There was no algebra involved. But you probably will guess that at some point, they're not just going to make this 34. They're going to make it what, like 5x or 2x minus 1 or something like that. Agreed? Yeah. And then you got to set them equal to each other, solve for x, plug it back in. Yeah, they're eventually going to do that. They just didn't do that with this example. They made it pretty straightforward, just a bunch of numbers. Let me take a look. What did I say that quiz was going to be over? 6.3, 6.4? I'm looking to see if we have any of that geometry. Yeah, there is. There's a couple of those. And I'm looking to see. Yeah, there are 2 problems where we're going to do that, what do we call it? That substitution stuff. All right, there's 2 problems where you're going to do the substitution. So we'll go back at the homework, look at them to review for the quiz so that you got that. We've done a lot of that substitution, okay? I've taught it enough, even though you might have not had it in Algebra 1, I taught it enough in here to expect you to know how to do that, okay? So there are 2 problems where you got to do that substitution. Yeah, so the first 4, you're going to have to do a little algebra. After that, 5 through 10 on the quiz, there's no more algebra. It's just like this. It's like just numbers, okay? Everybody with me? All right. So let's move on. Oops, what am I doing? Let's do this. All right. Let's do a couple more theorems, and then we'll be finished. Well, more than a couple, but. All right, this is kind of, it's all, I'm thinking about not even going over this because do you remember when we did the converse of those things? You remember about a parallelogram? Remember we said, let's just draw this. Let's draw a parallelogram. Just so you know what I'm talking about. Everybody's listening, right? Attention should be up here. Thank you. All right, so do you remember if I told you that this was parallel to this and this was parallel to this, then what is that 4-sided figure? It's a parallelogram, correct? Okay. We also said if these 2 sides are parallel and the same 2 sides are equal, what is this thing? It's a what? It's a parallelogram, yes? What if I told you that this angle and this angle are equal and this one are equal? Then what is this shape? Parallelogram, okay? You getting the idea, right? What else did we say? We talked about diagonals, didn't we? All right, what if I told you, because I don't know it's a parallelogram just yet. They didn't tell me. But what if I told you that, is it to go to the bathroom? No. All right, so look. What if I told you that AC was equal to BD? I'm sorry, I lied. We'll put an M right there. What if I told you this? I'm sorry. I was thinking ahead, all right, to the next thing we're going to do. This is all old. What if I told you that AM was equal to MC, and I also told you that DM was equal to MB? No, you don't have to. This is review. Okay, this is stuff that we've done in the past. Okay? So what if I told you that that these 2, like this and this were equal, and this one are equal? What could I say about the whole thing? It's a parallelogram. You get the idea, right? You remember doing that? Yeah. So this stuff that we're doing is kind of like that, except we're not just talking about parallelograms. We're going to be more specific. Okay, what were the more specific types of parallelograms? There's 3 of them. Rectangle, rhombus, and a square. Exactly right. So what if I drew this picture? Just looking at that, with the information that I gave you right there, right in front of you, what is that? Come on. I thought we had this figured out. It is a quadrilateral. Why? Because there's 4 sides. Can you say it's a parallelogram? Why not? I don't got enough information. That's exactly right. I don't know that the opposite sides are equal. I don't know the opposite sides are parallel. I don't know the opposite angles are equal. I don't know the consecutive angles are supplementary. I don't know anything about it, except it's got 4 sides. Agreed? Okay, so can I say that that's a rectangle? Does it look like a rectangle? Yeah, it does. But it doesn't mean it's necessarily a rectangle. All right? But what if I did this? What if I drew some diagonals? Now, just drawing those diagonals, does that make it a rectangle just because I put diagonals in there? I could put diagonals in any shape, right? Well, except a triangle. But anyway, anything bigger than a triangle, I could put diagonals in there. So right now, it's still not a rectangle. But what if I told you this? What if I told you that this is what I was going to write earlier and I had to erase it? What if I told you that AC was equal to BD? Okay, I told you that is true. Now, what can you say about that thing? It's a parallel. It's not just a parallelogram. It's a what? It's a rectangle. Because remember, what did we say? If it was a rectangle, then what must be true about the diagonals? They got to be equal to each other. Okay. So then we flip-flop it, right? We change the if and the then. If and the then, all right, and we say if the diagonals are equal to each other, then this thing is a what? A rectangle. Right? You see what we're doing? All right. It's kind of what we talked about earlier in this lesson yesterday, but it's a little different. All right. And they put it all in one lesson. All right. So if the diagonals of this thing right here are equal to each other, then it's a rectangle. So what do I know about this? Now I know that it's a rectangle. Why? Because I knew that the diagonals are equal to each other. Everybody good? All right, let's do another one. What if, let me draw this, and I'm going to try to make it look like it's a rhombus, but like we just talked about, okay, it's pretty close. All right. Right now, it looks like it's a what? It's a rhombus. But can I say definitively that that's a rhombus? No, I can't, because I don't know anything about it, right? But what if I did this? Let's put some diagonals in this. Remember somebody said earlier, oh, a lot of you guys agreed with it. When I did that rectangle, and I said, just by putting the diagonals there, does that make that a rectangle? And some of you are like, yeah. No, okay, because here I got diagonals, correct? Is that a rectangle? No, all right. Do the diagonals just by themselves make that into a rhombus? No. Okay, but what if I told you that this was a right angle? Now what could you say about it? Now you could say it's a rhombus. Everybody got that? Because what did we learn yesterday? We learned if you have a rhombus and the diagonals are perpendicular, if you have a rhombus, then the diagonals are what? Perpendicular. So we're just switching the what? The if and the what? The then. So instead of saying if it's a rhombus, then the diagonals are perpendicular, what we're saying is if the diagonals are perpendicular, right? We switch them, then it's a what? A rhombus. You see the difference? Right? We just took the if and the then and we switched places with them. All right? That's really what it is. That's called the converse of a statement. Everybody hear me on that? It's called the converse when I switch the if and the then. Not every statement, if I switch the if and the then, is true, but these theorems are. All right? So if I switch them, take the converse, they would be true. All right. Let's do another one. Let's talk about these diagonals again. I'll just keep that same picture there. What if I told you this? Let's get rid of the right angle. Let's pretend we don't know that's a right angle, okay? And pretend we're not sure if this is a rhombus or not. But here I'm going to give you some more information. Let's put this in a different color. What if I told you that this and this were equal to each other, and this one and this one are equal to each other, and these two are equal, and these two are equal? Now, what can I say about this thing? Not just a parallelogram, but I could now say it's a what? Now I could say it's a rhombus. Okay, I can check my notes. All right, so yes, this will be a rhombus. Why? Because the diagonals do what on a rhombus? They bisect each other. Okay, so if the angles are bisected, if the opposite angles are bisected by the diagonals, then this thing is a rhombus. So with that information right there, I can say 100% that that's a rhombus. We good? Okay. One more, like this. Oh, here's another one. I'll just keep those in there. Now let's get rid of them. Let's just start with a clean slate. Here's something that we really didn't learn before, but it's kind of brand new, right? We learned, what if I told you this? What if I said that this, and this were equal? I don't even care about the diagonals. Let's just get rid of the oops, don't want to do that. Let's get rid of that diagonal, get rid of that diagonal. There we go. What if I told you that? What could you say about this thing? What could you say about that four-sided figure? If all four sides are equal, then it's a what?
Parallelogram.
No, parallelograms. All parallelograms don't have all four sides equal. It's a rectangle. It's not a rectangle. It's a rhombus. That's right. When all four, by definition of a rhombus, right? What's a rhombus? It's a quadrilateral with four equal sides. Yes? All right. So that's a rhombus right there. But check this out. This is a little bit new, right? I don't even need to know all four. This theorem's a little bit new. All you need, it says if two consecutive sides, first of all, you do have to know it's a parallelogram, all right? So you have to know that, all right? So they tell us that's a parallelogram. All right, so if you have a parallelogram and it says if two consecutive sides are congruent to each other, I just got to know two. So what if I knew that that was 3 and that was 3 and this was a parallelogram? What could I say about this? This theorem says I can say that it's a rhombus. So if these two sides are equal to each other and it's a parallelogram, then what must be true? The other two sides. Why is that true? Is that just something somebody made up? Well, if it's a parallelogram, what's always true about the opposite sides of a parallelogram? They're equal. So if that's 3, what's this? That's got to be 3 if it's a parallelogram. Agreed? So if this side is 3, then what's this? That's got to be 3. Did I have to start off knowing that all 4 were equal to each other? No. All I needed to know is that 2 consecutive ones, okay, were equal to each other. One's next to each other. You see that? So that's kind of a proof for that theorem. That's why it's true. So if that's true, again, if all I knew about this thing is, first of all, that it was a parallelogram, and any two of the consecutive sides, the ones that are next to each other, not across, if I just know that they're equal to each other, that's enough information to say that this thing is a rhombus. So now I know, without a shadow of a doubt, that this thing is a rhombus. Everybody good? All right, we got one more, and then we'll take a look at some of the homework. Actually, I might just review for the quiz. I might not. I'll still give you the homework, but I'm gonna just review for the quiz. So that'll be on the same lesson. So if you want to watch the review for the quiz, continue and watch this video, and you'll see it. All right, here we go. These two lines, they look like they're parallel. Now they're parallel because I put the arrows there. Everybody here? Everybody with me? Seems like I'm losing a few. A few are dropping out. Heads are dropping on the desks. That's not a good thing. But if that's the way you want to be, I guess. End of the year, I'm not going to fight with you anymore. So watch this. What if I drew a perpendicular line to those two parallel lines? Perpendicular means it's what? 90 degrees. Everybody with me on that? Actually, yeah, let's do that. So if I was to, let's not do that yet. Let's say I wanted to do that. Let's say I pick a point on this line right here. And I wanted to find the distance between this line, this top parallel line, and the bottom parallel line. Okay, I want to find the distance. I want to measure. So if I gave you a tape measure, give you a ruler, something like that, and I said, okay, start at this point, and I want you to measure how far it is from this line to this line. Where would you measure? Would you measure to there? Would you measure to here? Let's not say straight down. I know what you're thinking, but let's say it more geometrically. Perpendicular, exactly right. So the distance from this line to this line is a perpendicular distance. We actually gave that a name. Do you remember that? From a point perpendicular to another line. It's a word that we've used quite often. If you have an airplane, right, flying along, and you want to find the what, how high it is, what is that? It's the altitude, that's right. Okay, so if I draw that right there, if I draw it perpendicular, this right there is the distance, okay, from a point on one parallel line to another point on the other parallel line. Or I shouldn't even say to another point. I should say it's the distance from one parallel line to the other. Okay, let's just say that. Everybody got it? So what if I pick another point on this line and I found the distance of that one? So what if I started here and I found the distance from this point to the other parallel line? Again, where would I go? Would I go to here where the other one met? No. Where would I go? Perpendicular, that's right. So I want you to tell me something about the length of these two distances. They're going to be exactly the same, right? Because there's no variation, right? If the lines are parallel, then the distance between those lines, no matter where on those parallel lines that you choose, I could have picked right here. I could have picked right here. It doesn't matter. That distance from one line to the other is always going to be the same. And that's basically what the theorem is telling you, all right? So if they told you that this was 5 and that they're both perpendicular, then what is this one right here? Then it's 5. That's basically what they're trying to do. It's kind of straightforward. I mean, you probably would have guessed that if I didn't even tell you, wouldn't you? Have guessed? Yes? Okay. You probably would have. All right, so these two and these two are equal. All right, that's enough of section 6.4. Let's talk about the quiz. We got about 12 minutes left. Rhombi is plural of rhombus. So if you have two rhombus, you wouldn't say rhombuses, you would say two rhombi. All right, so that's what the word rhombi means. All right, so here we go. Let's review for the quiz. So here's some things that you need to know. The first part's all about just general parallelograms. So 1 through 4 is just about parallelograms. All right, let me make it not look like a rectangle. All right, so here we go. What if I told you, I'm not going to put numbers in here. I'm not going to actually solve the problems, okay? But what if I told you that this was 5? What would this one down here be? 5. What if this was 3? What would this one over here be? But it's not just going to be numbers on the quiz. What do you think I'm going to put in there? X's and Y's and stuff like that, okay? On this one, you're not going to have to do any substitution, okay? This is straightforward. So this is going to be, I'm just making this up. I don't know if this comes out nice and even or not. I'm just making these numbers up. So let's say this was like 5x minus 2. Let's say that this was, I don't know, 3x plus 1. Okay, I don't know if that comes out nice. Don't even worry about that. But what would you do to solve for both of these lengths or solve for x? Yeah, you just set them equal to each other and solve for x. Make sense? It's the same thing over here, except these are going to be y's. All right, so these are just x, these are just y. You set them equal, you do some algebra, you solve for x, and that's what they ask for. You don't even have to plug it back in. All right, they just ask you to solve for x and y. Everybody good with that? So on number 1, they're just asking you to solve for x and y. So everybody should be able to get that one if you know how to do some real basic algebra. Come on, grab that thing. Where is it? Why can't I grab that? There we go. All right, let's do another one. Let's move down. That's easier. All right. Now we put some diagonals in here. And this one is no substitution. I think I said earlier that 3 of them were substitutions. Only 2 of them are. Number 2 is not a substitution. All right. So this is what it's going to look like. They're going to give you a value for this one and this one. Again, just like what we did before. There will be, it's A and B this time instead of X and Y. But this is going to be, I don't know, 5A. This is going to be like 2B minus 1. Or I'm sorry, not B. It's A minus 1. Again, those aren't the numbers. I'm just making that up at the top of my head. All right, but what would you do to these if this was a parallelogram, I tell you that this is a parallelogram, you would set them equal to each other, just like we did on number 1. Okay? So you just set those two equal. Why? Because if this is a parallelogram, what did the diagonals do? They bisect each other. So that means that this little part and this little part are equal. And then over here, you're going to have like 3b and then, I don't know, 9 or something like that. All right? You set them equal to each other, you solve for b. Set these equal to each other, solve for a, solve for b. That's your answer, just a and b. You don't even have to plug them back in. Just solve for a and b. It's pretty easy, isn't it? Yeah. All right, now, 3 and 4 are going to be the hardest problems that you do on the quiz because of the substitution. For some of you, it won't be hard at all because substitution is not that big of a deal for you. All right. I'm going to put some diagonals in here. Yep. All right, and that length is 25. This length right here is 20. And they tell you it's a parallelogram, by the way, okay? They have to tell you that. So it is a parallelogram. This one right here, let's do it right here, 12a minus b. And this one is 6a plus b. 6a plus b. Everybody good? And what are you going to do? Yeah, this is very similar to number 2, except the math is a little bit harder. That's it. You're going to have to do substitution on this one. All right? It's basically the same problem as number 2. So let's do it, though. What are we going to do? Let's do that 12a minus b. What's that equal to? 12a minus b equals what? That's a 20. Okay, 20. What else is true? 6a plus b, right, so 6a plus b is equal to what? 25. Now, if you know how to do elimination, right, if you learned that before and you want to do it, this is a perfect problem to do elimination, right? I'm going to do it by substitution because that's the way I taught you guys to do it, okay? But if you learned elimination in the past and you want to do it like that, feel free. What I would do is get either A or B by itself. What do you think the easiest thing to do is to get by itself? I would say the B. You could get this B by itself, but it's got a negative in front. So what do you think the easiest one? I would say this one right here. Get that by itself. So how do I get it by itself? Subtract what? The 6a. That's right. Subtract 6a. Everybody with me? So that cancels. B equals, let's just write it like this, 25 minus what? 6a. That's the first step. Just get b by itself. Everybody good with that? The only thing we did was subtract the 6a from both sides. That's it. Yeah. This is where we're going to substitute. Because b equals this. Do I have a b somewhere else? I got one up here. So guess what I'm going to do? I'm going to take this and replace or put it right there for that one. So instead of 12a minus b, I'm going to put what? 12a minus 25 minus 6a. But you got to be very careful, okay? You're subtracting two things, aren't you? So what are you going to have to do to those two things, that 25 minus 6a? Put it in parentheses, all right? So I'm going to rewrite this right here. I'm just going to write it down here where I have some more room. Is that all right? So it's 12a minus b. What's b? 25 minus 6a. Since there's two things and I'm subtracting, what do I have to do? I got to put it in parentheses. All right? And then I just write out the rest of the equation. There's 12a minus, there's my b, equals what? 20. And now I can just do some regular algebra and solve for a. Okay? So let's do that. What do I do with this negative in that parentheses? Give me a good word, math word. Distribute, that's right. So what I'm going to do, I'm subtracting everything in that parentheses, correct? So I'm subtracting the 25, And I'm also subtracting a what? Not a 6a, but a what? A negative 6a. So let's rewrite it. Let's go 12a minus 25 minus a negative. What's minus a negative? Positive 6a. That's the key right there. If you didn't put those parentheses in there, you would have gotten the minus 25, but guess what you would have done with the 6a? You would have made it what? Minus. But by putting the parentheses in there, that makes it a plus 6a. What we just finished doing right there was absolutely the hardest part of the problem. The rest is piece of cake. All right, so let's simplify this. 12a plus 6a. Let's add like terms. What is that? 18a minus 25 equals 20. And you see what we're doing now, right? Get rid of the minus 25. How do we do that? Add a 25. 18a equals, is this working right? Oh, okay, yeah. I was thinking it was going to come out even. I was like, this doesn't come out even. But that's okay. Watch. Divide by 18. Divide by 18. A equals, what divides evenly into both of these? What's the biggest number that divides evenly into both of these? 9 does. 9 goes into 45. How many? 5. 9 goes into 18. How many? Twice. So you could just write 5 over 2. Or you could write 2.5. Or you could write 5 over 2 or 2.5, right? That's the same thing as 5 over 2. Did you know that? So you could just write 5 over 2 if you wanted to. All right. But when we substitute it back in to solve for b, it might be a little bit of a problem. So you could write this. Look, how many times does 2 go into 5? Twice. So 5 minus 4 is 1 over 2. Remember how to do that?
Just
back in elementary, middle school?
Seniors, you'll have a meeting in
What's
the
2.5?
Next period at 10:35 today. So there's a senior meeting
2.5.
at 10:35 today.
5.
Just a reminder,
Okay.
we also be selling Chick-fil-A.
So either one of these answers would be perfectly fine. But now what do I got to do?
Thank you.
I found A. I found A. What do I got to find now? What? Did I lose you already? As soon as you heard Chick-fil-A, you're like, all right, I'm out of here. Look, A is 2.5. What do I got to find now? That's half the problem. I got to find B, right? So where do I want to put that? There's a lot of places I could put B. Let's put it right here. Remember this? Remember this right here? Let's put it in for that. Now, if you have a calculator, I would use calculator. So B equals what? 25 minus what? 6 times 2.5. All right? That's 12, that's 3, that's 15. Is that right? Yep. So B equals 25 minus 15. What's 25 minus 15? It's 10. You can always use a calculator if you wanted to on that. And there's your answer. So A is 2.5 and B is 10. That's how you do it. Well, I changed my mind again. We didn't have enough time to finish this up. I really thought we'd be able to finish this up. So we'll take the quiz on Monday, okay? So we'll do some more review. But you do have homework tonight, okay? Your homework is whatever. It's 1 to 11. It's Wednesday. It's for Wednesday, though. All right? It's whatever's on Wednesday. It's 1 through 11. So it's section 6-4. So we got a little behind this week, but that's okay. So 1 through 11, that's your homework. That's due tomorrow, okay? That's due tomorrow.